All right, we're going to continue on with the segment addition postulate today, but today, instead of just solving for x, we're actually going to be finding the lengths of certain segments. So let's just go ahead and start off with example 1. For example 1, we need to find VU, and we are given a line segment, which is WVU. This part, WV, is x minus 1. VU is x, and the whole thing is 21. All right, in order for us to find what VU is, and VU is this section right here, we first need to find out what x is. If we know what x is, we know what VU is. So we're going to set up our equation just like we did yesterday. We're going to do x minus 1, x plus x equals 21. We're going to put together our like terms, so x plus x gives us 2x minus 1 equals 21. Add 1 to both sides. 2x equals 22. Divide by 2 and we get x equals 11. Now, we're not done until we plug in, but in this case, our VU is just equal to x. So since VU is equal to x, all we need to do is plug our value into x. So VU is actually going to equal 11. All right, let's look at our second example. For our second example, we're going to find KL. And we're given our line segment, which we have K, L, and M. K is given as 2x minus 19. LM is given as x plus 1. And the whole thing, KM, is given as 15. So again, before we can find out what KL is, we need to know what the x value is. So we're going to set up an equation and solve for x. So we have 2x minus 19 plus x plus 1 equals 15. Now we're going to put together our like terms. 3x, 2x plus x gives us 3x. Then we do negative 19 plus 1, which gives us negative 18. And then we add the 18 to both sides. We get 3x equals 33. We divide by 3, and our x equals 11. But again, we're not done with our problem because we need to find out what KL is, which is this piece right here. So KL is 2x minus 19. So again, what we're going to do is where the x is, we're going to plug in 11. So we have 2 times 11 minus 19. So doing our order of operations, multiplication comes before subtraction. So we do 2 times 11, which is 22. We subtract 19, and KL equals 3. And since that's what we were asked to find, there is our answer. All right, looking at our next example, we need to find SU. And we have our line segments. This is S, this is T, and this is U. So we have 7x for ST, 11 for TU, and the whole thing SU is 18x. All right, so again, Before we can find out what SU is, we need to know what X is. So we need to set up our equation. The two pieces add up to the whole. So we're going to do 7x plus 11 equals 18x. And normally I like to subtract my variables from the right side and swing them over to the left. But in this case, it makes more sense to subtract this guy over to the right-hand side. So we get 11 equals 18 minus 7, which is 11x. We divide by 11, and x equals 1. But again, we're not done because we need to find out what ST is. SU. So SU is this right here, 18x. So we're going to take our 1 and plug it into our x. We'll do 18 times 1. So SU equals 18, and that is our answer. All right, looking at our next example. For our next example, we need to find AC. And we have our line segment, which is ABC. AB is 2x plus 15. BC is 10. And the whole thing, AC, is x plus 19. So just like we did on the last problem, before we can find out what AC is, we need to find out what x is. So we're going to do exactly like we did on the last problem. We're going to solve for x. So first we set up our equation. AB is 2x plus 15. BC is 10. And AC, the whole, is x plus 19. So we start off by combining our like terms. 15 plus 10 gives me 25. I'm going to subtract my x from both sides. So that gives me x plus 25 equals 19. Subtract our 25 from both sides. And x equals a negative 6. But again, we're not done because we need to find out what x plus 19 is here for AC. So we're going to plug it in. Negative 6 plus 19 is going to give me a positive 13. So that'll be our value of AC. Let's look at example 5. For example 5, we need to find Km. So Km is what we're looking for. We have our line segment, K, L, M. KL is given as 10 plus x. Let me correct that. 10 plus x. LM is given as 11. And our whole thing, Km, is 2x plus 21. And again, we're finding this whole thing, Km. So we first need to do, to find x, so we need to set up our equation. So we're going to set up the two pieces, 10 plus x plus 11 equals 2x plus 21. Now what we need to do is combine our like terms. So we have x plus 21 equals 2x plus 21. We're going to subtract our 2x from both sides. We get a negative x, or negative 1x, plus 21 equals 21. We're going to subtract our 21 from both sides. We end up with a negative x equals negative 21. Since we have a negative x, we need to divide by negative 1. And we get x equals 21. I'm sorry, I screwed that up. Let me go back. 21 minus 21, I don't know what was going on in my head. That should give me 0. So we're going to divide by -1 and we get x equals 0. Now what we need to do is we need to take that and plug it in for 2x plus 21. So we're going to do 2 times 0 plus 21. Again, the multiplication comes first, so 2 times 0 is 0, plus 21 equals 21 for our Km. And that is our answer. We have one more example to look at, and that is we're going to find LK. We're given our line segment, which is LKJ, L, K, and J. LK is given as 3x minus 3. KJ is given as 2x, and our total LJ is given as 12. So this time we are solving for LK, which is right here. But just like we did on the last problems, before we can find out what LK is, we need to know what x is. So we're going to do an equation, 3x minus 3 plus 2x equals 12. Put our like terms together, 5x minus 3 equals 12. Add the 3 to both sides. We get 5x equals 15. Divide by 5, and our x value is 3. But again, we're not done because we do need to plug it into 3x minus 3. So we're going to plug our x in, our value right there, 3 times 3 minus 3. Well, again, following our order of operations, 3 times 3 is 9, minus 3 gives us 6. So that is what LK is. And that is our final example.